A very good morning, children. Welcome back to the next session on electricity. In the last class, we studied about Ohm's law, resistance, factors affecting the resistance of a conductor, and also we saw resistivity. Today, let us know about resistors. What do you mean by resistors, children? Resistor is nothing but it is an electrical component that limit or regulate the electrical current. Any electrical device which allows only limited amount of electric current to pass through it is called as a resistor. So, a resistor is anything. So, which is not allowing the electricity to pass through it easily. I can say, though the electricity is passing through the resistor, but the flow of electricity is not so easy. So, because resistors is offering the resistance to the flow of current. So if we take the example of a resistor, so we can take the example as fan, bulb, TV, etc. Whatever the electrical appliances you are using, so they are all the examples of the resistors, children. If suppose we consider these resistors are connected in series, then let us check how the equivalent resistors of the total resistance will be. See children, here I have a circuit diagram. In that circuit diagram, I have three resistors. See, these three resistors are connected in series. That is, they are connected end to end. So, I have the first resistor which is called as having a resistance R1. Second resistor is having a resistance R2. And the third resistor having the resistance R3. All these three resistors, that is R1, R2, R3, are connected in series. Okay. Then I have an ammeter, so which is connected in series to these resistors. Okay. Then I have a battery or a cell. So then this is called as a switch or a plug key. Remember, always the current will pass through from positive end of the battery to the negative. That is, the electric current will pass through in this direction. That is, from positive to negative. Okay. Now, if I want to calculate the voltage across the resistors R1, R2, R3, so voltage is nothing but in order to pass the electric current, I need a potential difference. So for that potential difference, I have attached it to the battery which will create the potential difference. If I want to know the voltage across the resistor R1, then what I need to do is, if I consider that voltage across the resistor R1 is V1, okay, then we have a Ohm's formula, that is V is equal to IR. If V1 is the voltage across the resistor R1, then I can write this relation, that is Ohm's law, as V1 is equal to IR1. Similarly, if I consider V2 is the voltage of the second resistor, that is R2, then V2 is equal to IR2. So, if suppose V3 is the voltage of the resistor, that is the third resistor, then I can use the relation, that is Ohm's law, and I can write V3 is equal to IR3. So remember, the same current is passing through R1, R2, R3. That's why I have not mentioned I1, I2, I3. So whatever the current which passes through R1, so the same current will fall to R2 and then to R3. Remember, the current across the circuit will be the same. The current passing through this circuit will be same. Whereas the voltage across R1 is different from across R2 and R3. That means, so resistor to resistor, the voltage differs. If I want to calculate the voltage across R1, then what I need to do? I need to attach it with a voltmeter. Okay. So now voltmeter is a device which measures the voltage across a resistor. So when I connect it, remember, so the voltmeter is connected across the resistance R1, so in parallel. When I connected this voltage in parallel, so remember, whatever the reading it shows is nothing but it is V1. Okay. Then similarly, if I connect the voltmeter across the resistor R2, then the reading which we get will be the voltage V2. If I connect this voltmeter across R3, then I am going to get the voltage V3. So I have a relation here now, children. According to the Ohm's law, I have written, so V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Now, I need to find out what will be the total voltage across this circuit. What will be the total voltage which is so being flown through these resistors. In order to calculate that, what I need to do is, I have to use a relation. The total voltage, that is V, is equal to, it is the sum of V1, V2, V3. So because all these three voltages are being involved in the circuit. So therefore, if I add these three voltages, that is V1, V2, V3, then I am going to get the total voltage across the circuit, that is from R1, R2 and R3, okay, in the circuit. So now substitute these values, that is V1 is equal to IR1. What is V, children? V is nothing but it is IR. So I is the total current, R is the total resistor. Then V1 is IR1. Similarly V2 will be IR2, V3 will be IR3. So now I need to find out the common terms in the RHS part. Can you see any common term in these three terms? IR1, IR2, IR3? Yes, I is a common term. So that is current term is a common term. Therefore, I can take it outside the bracket. I can write IR is equal to I into R1 plus R2 plus R3. Since I is a common term in both LHS and RHS, I can cancel it with each other. Then the remaining part I am going to get is R is equal to R1 plus R2 plus R3. What is this? R is called as total resistors, or I can say it is a equivalent resistance. Okay, equivalent resistance in series is nothing but the sum of the resistors which are connected in series. Since I have connected three resistors in series, therefore, the equivalent resistance will be R1 plus R2 plus R3. So understood, children? So wherever the resistors are connected in series, the total resistance or the equivalent resistance will be nothing but it is the sum of the resistance which are connected in the series. So remember one thing, always the ammeter will be connected in series, whereas voltmeter is connected in parallel. In series, you have to note down one more point. What it is it, children? So it is nothing but, so the same current will pass from R1 to R2, again from R2 to R3 in such a way that the same current will pass from positive end of the battery to the negative end. The current divisions will not be there in the series. Whereas the voltages differs from resistor to resistor. So if I consider R1, the voltage will be V1. If I consider the resistance R2, then the voltage will be V2. If I consider the voltage, that is V3 across the resistance R3. So I hope you have understood, children. Now let us see, if suppose these three resistors are connected in parallel, then what might be the equivalent resistance? So before going to the parallel connection, you might be asking a question where this series connection is applicable. Where and all we will use the resistors in series connection. So the very best example is lightning that is done during the housewarming ceremony, wedding, etc. In such lightnings, bulbs are connected in series, children. So remember, so you have got the most important application, that is during the lightnings. Okay. Now let us go for the resistors which are connected in parallel. Here also I have written the Ohm's law, children, that is V is equal to IR. In this circuit diagram, here also you can see the three resistors, that is R1, R2, R3. But there is a one difference, that these three resistors are connected in parallel. They are not connected from end to end, but they are connected through a junction. So I can say this is one junction and the another point, that is this is the second junction. And also you can see the ammeter, okay, then the battery and the plug key. Along with that, you can notice one more point, that is I have connected the voltmeter in such a way that it is parallel to all the three resistors, that is R1, R2 and R3. Okay. So here you have to notice one point, children. Ammeter is connected though in series, but because of this junction, the same current will not flow here. Okay. Same current will not flow here. So I can say only some part of current will pass through the resistance R1 and some pass through R2 and then remaining will pass through the resistance R3. That means the current, the total current is being divided among these three resistors. Suppose, so I can say the current which is passing from R1 will be I1 and the current which passes through the resistance R2 will be I2 and the current which passes through R3 will be I3. So, but the voltage across these three resistors is same. So, what you have to notice is, as I've said in series voltages are different across the resistors. The current was same, isn't it? But in parallel, the current that is flowing through the three resistors which are connected are not same. So, okay, whereas the voltage is same. Okay. Therefore, what I will do is I will rewrite the formula, that is Ohm's law, as I will just shift this resistance to the LHS part. I can write V divided by R is equal to I. Why I have shifted this, children? Because I need to find out the total current that is flowing through the circuit. Because the voltage is the constant across the circuit. Therefore, the thing that is varying is the current. So, I need to find out the current that is flowing across the circuit, that is from R1, R2 and R3, etc. So, in order to find that, what I need to do is, as I have said, I1 is the current that is flowing through the resistance R1 and I2 is the current that is flowing through the resistance R2. I3 is the current that is flowing through the resistance R3. So, according to the formula what I have written now, that is I is equal to V by R. So, I can use the resistance R1 and current I1 as I1 is equal to V divided by R1. Similarly, I2 is equal to V divided by R2 and I3 is equal to V divided by R3. I can say only I1 current will pass through the resistance R1 and I2 current will pass through the resistance R2 and the remaining I3 current will fall, that is pass through the resistance R3. Understood? Now I need to find out the total current that is passing through the circuit. How to find out the total current now, children? Just add these three current, that is I1 plus I2 plus I3. So therefore, the total current that is flowing through the circuit, that is I is equal to I1 plus I2 plus I3. What is this I is equal to? Which is nothing but V divided by R. V is the total voltage, R is the total resistance. So similarly, I1 is nothing but V divided by R1, I2 is nothing but V divided by R2, I3 is nothing but V divided by R3. Let us substitute it, children. So we have substituted that V divided by R is equal to V by R1 plus V by R2 plus V by R3. So you can notice that in RHS part V is a common term. So if I take V as a common term, then I can write V divided by R is equal to V into, inside the bracket I am going to be remain with 1 over R1 plus 1 over R2 plus 1 over R3. Okay. So remember, so V is a common term even in LHS as well as in RHS. Therefore, V is cancelled in on both the sides. So after cancelling out on both the sides, what we are going to remain with? We are going to remain with 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is nothing but the equivalent resistance when the resistors are connected in parallel. Remember, so the equivalent resistance is nothing but the reciprocal of the sum of the reciprocal of the resistance. Okay. So you can observe one more thing, that in parallel the current that is passing through the resistors which are connected in parallel are not same. They are being divided because of the junction that is being formed. Okay. And in parallel the resistors are connected through the junction in parallel to each other. And voltmeter as usual, it is connected parallel to all the three resistors. That is to say, the voltage that is passing through across these resistors are same. So ultimately we have gone the formula, that is 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So you might be asking about the application of these resistors in parallel. So in most of the cases we see the resistors are connected in parallel. So the very best example is our house itself. So you can see most of the electrical appliances, maybe fan or electrical bulb or a fridge or a refrigerator or AC cooler, almost all the electrical appliances are using the parallel connection. Okay. Now let us see the resistors in series and resistors in parallel. So, which is the term which is constant in series, children? I have mentioned here, that is the current. Current is same across the resistors R1, R2, R3. So, what is the thing which is constant in parallel? That is voltage. I have written here V. So, voltage is same across the resistors which are connected in parallel, whereas current is same across the resistors which are connected in series. And the equivalent resistance that can be calculated in series is R is equal to R1 plus R2 plus R3, whereas if I take the resistors in parallel connection, then the equivalent resistance is 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, as we've said earlier, most of the electrical appliances which are used in our houses are using the parallel connection. Why can't they connected in series? Why they are connected in parallel? So, because of the advantages of the parallel combination. Let us see what is the advantages of connecting the resistors in parallel than that of in series. Okay, let us see one by one these 3 points. In series, when one resistor fails, the circuit is broken and non-component works. That means, as I've said, so in series, if I take the example of the lightning in the great, that is a wedding day or a housewarming ceremony, you might have observed that if any one of the bulb uh, got damaged, then the whole line of the lightning set will not glow. It will not glow. That means if any one of the resistors fail, then the whole circuit is broken. That is to say, the same current, because the current is same across the resistors in series, the same current has to pass from R1 to R2, then R2 to R3. Remember, if R1 is circuit is failing because of some misconnection, then R2 and R3 won't work. Understood? So therefore, series connection is not holding good. If suppose one of the resistors fails, then the whole circuit will not be working out. Okay. Whereas in parallel, just think of parallel connection, children. Here this is R1, R2 and R3. If suppose R1 resistor is being failed, then the current, though the part of the current which passes through R1 is being failed, but the I2 and I3 will follow through the resistor R2 and R3. Therefore, though the one of the electrical component fails, all the other resistors will work out. Therefore, we always prefer the resistors in parallel connection. These days, even for the lighting purpose also, they are using the parallel connection. So now let us see the second advantage of parallel combination, children. That is, different appliances require different current. As I have said, I have given the example like a fan, then electrical bulb, then the mixer or the refrigerator or the washing machine or a AC cooler. So almost all the electrical appliances require different current. So this cannot be satisfied in series combination. If I take the example like R1, R2, R3, if I take this R1 as a fan and R2 as a AC cooler and R3 as a electrical bulb, R3 requires less amount of electric current to glow, isn't it? That is, a bulb requires only less amount of current, whereas fan requires little more current, whereas AC cooler requires much more current than these two. So, but the current which passes through the resistor in the case of series is same. So, whatever the current which is passing through the fan, the same current will pass through the AC cooler and the same current will go for the bulb also. Whether it requires or not, the same current has to pass through. So that's why the resistors in series is not applicable for the connection of the home appliances. Whereas come to the parallel connection, children, if I consider this first resistor as a fan, only a little amount of current will pass through the fan so as to work out. Whereas if I consider the R2 as a AC cooler, it takes more amount of current to work. And if I consider the third as a refrigerator, the different amount of current, that is I3, will pass through the electrical refrigerator. Like different electrical appliances require different amount of current, that is possible only in case of the resistors that are connected in parallel, because here the current is not same. Understood? Now let us see the third example. The total third advantage. the total resistance in parallel combination is less as compared to the series combination. See here, the total resistance R is nothing but the sum of the resistance. The resistance what we get from the three resistors is being added up. Whereas in parallel connection, the resistors are added, but they are added with the reciprocal. If the suppose the resistance R1 is about 2, then 1 over 2 is nothing but 0.5. Okay, so that the resistance will be decreased. The equivalent resistance will be decreased in parallel compared to series. I hope you have understood today's class, children. So it is now the time to take down the homework. So take down the homework question. The first question is, what are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? Just now I discussed the 3 points, children. You have to write down those 3 points. Define the resistors and give any 2 examples. So you have to define the resistors what I have dealt in the my first very beginning of the class. So write down the definition of the resistors and give any 2 examples. Okay. I hope you have enjoyed the today's class, children. So thank you for watching the class. Have a good day. Stay at home and be safe.